I don't know why my video got cut off. So here I go. So here's the other part of my hyperbola. And then I want to put my C values in at 10. So all the way from the center all the way to 10 would be my foci. So if I was going to do that again, my actual parts of my hyperbola are only the blue parts right there. What would be the equation of this asymptote? I just went up 6 and over 8. So 6/8 is a 3/4 slope. So y equals plus or minus 3/4 x would be the equation of the asymptote. All right, so I've got 2 more hyperbolas that I'm going to do, and then I'm going to give you an overview about parabolas. So this says, let's try graphing some when the center's not at 0, 0. So the only thing that's going to change is where my center is. This one happens to be left by 2, because in with the x it says plus 2, and up 1. So -2, 1 is the center of this hyperbola. But now I go about it just like I did before. The transverse axis this time is horizontal, so it's going to look like this when I'm finished. The A value would be 3, and the B value would be 7. And when I do 9 plus 49, I get 58. And what is the square root of 58? 7.6. So now I'm going to draw in what I know. So horizontally, I go 1, 2, 3, 1, 2, 3, and vertically I go 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Draw in my rectangle. That's my box that just does the framework for my asymptotes. Draw in my asymptotes. And recall that this is supposed to be a horizontal hyperbola. So I'd start at this point and move outward. And then I need to write the equation of my asymptotes, but this time the center's not at 0, 0. So I use point slope form. So point slope form is y minus y1 equals mx minus x1, where y1 and x1 are points that are on the line, and you want to use the center as your point because both of your asymptotes pass through the center. If you prefer to write 2 different asymptotes and use the y-intercept, go for it. This is just a broad overview that I probably won't even worry about the equations of the asymptotes if you had to graph these, but so y minus 1, right, because the center is up 1, equals plus or minus the slope, which was up 7 over 3, x plus 2, because we were left 2. So that would be those 2 lines. All right, so this last one looks like we have to put it ourselves in conic standard form. If you notice that the 4x squared is negative, that's kind of the giveaway that this is not an ellipse. One of these has to be negative. So we're going to put the 9y squared first because you want to put the positive term first. So I group together my y's and my x's, and I move my 4 constant to the other side, add 4 to the other side, factor out a 9, y squared minus 4y, factor out a -4, x squared minus 2x. What do I add in here to complete the square? I'd have to add 4. 9 times 4 is 36. I would have to add 1. -4 times 1 is -4. So my standard form, well, I'm not quite there yet, would have to be 9 times y minus 2 squared minus 4x minus 1 squared would equal 36. So I still have to divide through by 36. I'm going to write my equation down here. So if I divide everything by 36, I'm going to get y minus 2 squared over 4 minus x minus 1 squared over 9 equals 1. So just like an ellipse, I need to have it equal 1. I'm going to go to the point 1, 2. So 1, 2 is the center of my hyperbola. It's going to be vertical. Vertical 1, 2. And my a value is 2 from here. My b value is 3. So I go 2 vertically, 3 horizontally, make a box, draw in my asymptotes, and what did we say, vertical, so it's going to go up top, down here. My c value, 4 plus 9 is 13, so the square root of 13 is my c value. It is 3.6. And so I go 1, 2, 3.6, 1, 2, 3.6. And the equation of my asymptote going through my center would be y minus 2 equals plus or minus, what was the slope? Up 2 over 3, x minus 1. So that concludes our overview about hyperbolas.